Now we are going to discuss the important data structures. Let's first start with an example where we try to generate 10 random integers between 0 and 100, and then try to find the minimum and the maximum values among these 10 numbers. So to generate random numbers, we're going to use the random module in Python. Therefore, we import random module, and this way we will be able to call the randint function in the random module, which generates an integer value between the parameters that are given. So in this example, our lower limit is 0 and upper limit is 100, and this is an inclusive range, which means randint may also return the values 0 or 100. That's also possible. So whatever it returns, that will be assigned to the number, and this is being done inside a for loop for 10 times. So the for loop counter underscore will be initially 0. In the next iteration it will be 1, 2, it will go this way. Anyways, number becomes a random value between 0 and 100, and we first print it on the screen, and then we check if it's less than min. Now note that min was initialized to 100 and max was initialized to 0. Now this is, I know, not very intuitive at the very beginning, because we would expect minimum to be smaller than maximum, but it's the other way around. And there's a reason for this. We haven't picked any number yet. So initially we make min the largest possible value, so that when we start generating these random numbers, typically they will be less than this min value, because min is the largest possible value here, which is 100. So if we pick a number that is smaller than the initial value of min, which is 100, for example, if a number becomes 60, 60 is less than 100. Therefore, this condition will be true. Therefore, min will become number. In other words, min will become 60 in this case. Okay, so similar thing is done, just the inverse is done for maximum. So we initialize maximum to be the smallest value, so that the number we pick in the variable number, if it's greater than that max value, then that will be assigned to the max variable. This way, for example, if the first value that's generated is 60, both min and max will become 60, because up to this point, the smallest value we have seen is 60. Similarly, the largest value we have seen is 60. In fact, it's the only number we have seen up to now. But in the next iteration, let's say this time the random number happens to be 40. Now, since number, which is 40, less than minimum, which is 60, minimum will now be set to 40. But remember, max was also 60. Since number is 40, 40 greater than 60 is an incorrect proposition. Therefore, max will not change. Max will remain as 60, whereas min has become 40. Well, up to now, the smallest value we have seen is 40, and the largest one we have seen is 60. And it will continue this way for 10 iterations. So at the end of the for loop, we can just write the minimum and maximum values, and it would work. Just to try it, let me just copy this and then paste it to our editor, and let me run the program. See, it has generated this time. Let me just extend this part. It has generated randomly the values 55, 5, 34, 36, 64, 70, 23, 95, 98, and 86. The smallest value that's observed is 5. Really, min is 5. And the maximum value we have observed here is 98. So max is 98. So it works correctly. So now we can talk about the data structure named dictionary. A dictionary is similar to the list or tuple data structures we discussed earlier. However, the difference is that, remember, in the case of list or tuple, the individual elements were actually single values. Well, it could be anything, of course. It could be integer, string, double. As you will see later, even it could be a list itself. But this time, the in the case of dictionary, each element is actually a pair. So there are actually two different things stored there, and they are somehow associated with each other. The first one is called the key, and the second one is called the value. So for this key, this is the value. So this is one pair. Another element of the dictionary will be another pair. So it will be for the new key, it will be the other value. So it works this way. Here's an example. We are defining a dictionary named bookshelves, which is actually storing the name of the book versus the shelf number. For example, for the first element, now altogether, the highlighted part is one element of this dictionary. But note that just in here, where the red mouse pointer is, in here, the first thing is separated from the second one using the colon character, the two dots. Okay, so the first one is the key value. So the string, the grapes of wrath, is the key value, is the key. The second one, A2S5, is the value that corresponds to this key. So the key together with the value makes one pair, and that's the first element. The second element is now this one, where the key is this time Harry Potter and the Goblet of Fire, and the corresponding value is B7S2. And this is the last element. So the name of the book is The Hobbit, that's the key, and the corresponding value is a shelf number, which is B7S2, which is the same as the previous one. So note that two different key values map to the same value. That's possible because these two books are on the same shelf. When you say print bookshelves, and assume we didn't have this highlighted part, so if we just wrote print bookshelves, it would write us the whole dictionary. So let me show that for you. Let me just overwrite it like this. Let me also clear my output. Now, let me just cut the highlighted part. So I'm just printing bookshelf, which is a dictionary. So when I run it, you will see that it's printing the whole dictionary over here. Okay. However, if I put back the part that I printed, this time it will just be printing. Now see, this is the key we're searching for, because we say bookshelves in square brackets, the grapes of wrath. So this is the key we're looking for. Therefore, the corresponding value is A2S5. So when we run this, it will print only A2S5. Okay. One important thing you should note over here is when we're defining a dictionary, we are using the curly brackets, like the set sign. However, when we're talking about a specific element, the key value that we're providing is not that between square brackets, not the curly brackets. Okay, so let me return back to our slide. So this is a very simple dictionary with 3 elements, where each element, as I said, is a pair of a key and a corresponding value. Now note that in the case of dictionaries, the elements should be pairs, but they could be pairs of anything. For example, we're now in this case defining a new dictionary we name as dictionary of everything. So the first element, now forget about this because this is the comment that starts with the sharp sign. So ignoring the comments, this is the first element. So the first element of our dictionary is the string my favorite number and the corresponding value of 8. The second element of the dictionary is the integer value of 3 as key, and the corresponding value is the string 3. Whereas the third element has the key as the string the bookshelf dictionary, and the value corresponding to this key is actually this whole dictionary. In other words, a dictionary can have a dictionary inside. Okay, so it could be anything. Note that the first and the second are also, the first one is from string to integer, whereas in the second one it's from integer to string. So the elements could be quite different in type from each other. Anyways, now let's look at a new example. This time we have two arrays, runtime dictionary and even odd dictionary, but note that different from the previous examples. This time these two dictionaries are initially empty, so we define runtime dictionary and even odd dictionary as two empty dictionaries. Then in a for loop, again 10 times, for each value, so when you say range 10, as you will remember, it starts from 0 all the way to 10 minus 1, in other from 0 to 9, 10 is not included. So in the first iteration, for example, the underscore, the loop counter, will be 0, then it will be 1, 2, 3, 4, it will change this way. Now, when the loop counter value is divisible by 2, that means it's an even number. So in that case, the even odd dictionary will say whatever the value of the underscore is, an even number. Okay. Note that the underscore is an integer value and is an even number is a string, so you cannot add an integer and a string. So what we do is we take that integer value in underscore, the loop counter, and convert that value to a string variable so that we're adding two string variables, which is, as you will remember from our earlier discussions, which is actually concatenation of these two strings. So in other words, for example, in the first iteration, underscore will be 0, so it will be 0 is an even number. When it is 2, again it will say 2 is an even number, or 4 is an even number. Okay. However, since the value is increasing one by one, so initially it will be 0, but in the next iteration underscore will be 1. So this condition here, 1% 2, will not be equal to 0. Therefore, we will go to the else part. So the runtime dictionary is now not 2 times the value of underscore, but it is 3 times underscore. And in the even odd dictionary, it will just say, for example, 1 is an odd number. So you can guess how the program will run, but anyways, let me still show it. I will run this program. Anyways, when it runs, it just clears the output screen. And see, the first thing I'm printing is a runtime dictionary. So for 0, it's 0. For 1, it's 3. For 2, it's 4. So in other words, for even values, if the key is an even number, the corresponding value is twice that key value. But if the key is an odd number, then the corresponding value is this times 3 times the key value. And that's exactly what we see. For 1, it's 3. For 3, it's 9. For 5, it's 15. So it's always 3 times the key value. and for the evens it's just 2 times. And for the second dictionary, which was even odd dictionary, it's for 0, 2, 4, 6, 8, whatever. For these it says it's an even number, for the others it says it's an odd number. So it's quite easy. One thing to remember is actually we did something like this for the lists, and it works also for the dictionaries. So look at what we're doing over here. We're defining a new dictionary. Remember, a dictionary is composed of elements where each element is a key, colon, then the corresponding number, a corresponding value for that key. Now in here, ours will be x for the key, and for the value it will be 2 times x. However, this is to be repeated according to this highlighted part. So we're not creating a dictionary of a single element. Anyways, x was not defined until we have this highlighted part. And the highlighted part says, well, x will get its value from the range from 10 to 50, but with increments of 2. Remember, if you don't have the third increment, that means increment by 1. But if it's different from 1, we typically put that value there. In this case, it's 2. Then that means it will start from 10. And range will return values 10, 12, 14, 16, 18. It will work this way, all the way up to 50. But remember, when we say range, the second parameter is not inclusive. That means 50 is not allowed. So it's up to 49. But since we start from 10, and we increment with 2, with the value of 2, that means the last value would be 48. 49 will be skipped, and 50 is not included. So as I said, the last value would be 48. So if you want, we can try this again in our Java interpreter. So let me just run it. Anyways, it will raise the output. So yes, 10 to 20, 12 to 24, 14 to 28. So as you see, it is whatever x is, the value for key x, the value is 2x. And this is x is starting from 10 all the way up to 48. Now, the last example we have in this slide is for drawing shapes using characters. So the idea here is, now these characters over here are called the pipe sign. So that vertical line is a pipe sign. So it is pipe sign, some number of blanks, then some number of x's, again blanks, and then finally for closing on the right side, we again have that pipe. So that's how these rows are created, okay? And how do we do that? Well, we have a function. We define our own function named xprint, which actually prints the first pipe character, some number of spaces, then some number of uppercase X characters, again spaces, and finally again the pipe sign. So this is done for each row. But for each row, the number of X values could be different. So what we do is the following. Now, first of all, before going any further, I should explain this. The function xprint takes 2 parameters, x and line width. But as you see, line width is also initialized. This is called the default parameter. And if you look below, you will see that the xprint function is being called with a single parameter, not 2. So in the definition, we have 2 parameters, x and line width. But at the call, we're only providing the first one. So Python allows us to do this. You can skip these default parameters, okay? But we can do this only because it was initialized. That's how it becomes a default parameter. So if we didn't have that equals 40 over here, it wouldn't be a default parameter, it would be a regular parameter. And if you provide a single parameter to a function with two parameters, you would get an error message. But in this case, if we don't provide the second parameter, it's initialized to 40. If you provided, for example, if here you said x, say 60, in that case, line width would be initialized as 60. Okay, so it's 40 if and only if it's not specified at all. So anyways, what do we do with that? We take line width and subtract the first parameter. So subtract the first parameter from the second one, and then divide that by 2. Remember, this double slash sign means floor division or integer division. So we just throw out the decimal part. So that becomes spaces. Actually, the value, this variable spaces, is actually showing the number of space characters here we should place after the pipe sign. Okay, and that's exactly what we do over here. In print, we first print a pipe sign, then behind that we print the string, a single space string, but that is times spaces, as you see over here. Remember, when we have a string times an integer value, that means the string is to be repeated so many times. So in other words, we're going to write a single space, but how many times? It's spaces times, whatever that value is, 20, 30, 10, whatever that value is. Then followed by x. How many times? Well, determined by this small x, because we have x multiplied by the character x multiplied by the integer value x, so it will be so many occurrences of x, and then again some number of spaces, and finally the closing pipe sign. Okay, so whatever line width is, remember, we subtract x from that. X is the number of x values here. So 40 is the total here, the total size over here. Whatever the number of x's is, subtract that from that, and then divide by 2. When you divide by 2, then it shows only the spaces to the left, and the same number of spaces will also be placed on the right. We'll do that later. So that's what we exactly do over here. But what's the number of x's? In the first line over here, when I highlight it, you will see that in the first line we don't have any x's. Therefore, the number of x's is 0. Then in the following lines, here we have 10 of them. That's why these go as 0, 10, 10, 10, 10. And finally, also for the last line, we again have a 0. So that's for the shape of a square, or on the screen it looks like a rectangle because the characters are, the height and the width of the characters are not equal. But if they were equal, it would be a square shape. Anyways, now what's this shapes over here? Now, first of all, I know shapes is a dictionary. Why? Because it is defined in curly braces. Well, sets are also defined with curly braces. However, each element is a key, then the colon sign, then a corresponding value to that. Okay, so it's from a string to a tuple. And the contents of the tuple are actually the number of x characters in the first row, second row, third row, fourth row, whatever. It goes this way. So for the case of square, the first and the last are 0, and all of this are equal, 10. However, for example, in the case of triangle, in the first row it's 0, but then it goes as 1, 3, 5, 7, 9. Well, if you look over here, you also realize that we have 1, 3, 5, 7, 9 x values. So these are the number of x values in each row, and to calculate the number of blanks, you should be subtracting these number of x's from 40, but we will have blanks, equal number of blanks to the left and to the right. Therefore, we divide it by 2. Okay, that's what it does. Similar for the others. I will not go over each one by one, but these are basically similar. Actually, these are combinations of the others. What I mean is the following. Like, if you look at this one, it is 2 triangles, one regular and the other one upside down. Or if you look at this one, it is, now again, 2 triangles, but one is upside down, the other is just straight up. And this is actually 2 rectangles, and this is, for example, a square, and on top of that we have a triangle. So that's some, these are done, but I'm just leaving that as an exercise for you to try. So the next thing we are going to discuss is the len function. Len function, len stands for length, in fact. That means the number of elements in this data structure. You can use the same len function for lists, tuples, sets, and dictionaries, for all of them. So, for example, we define variables named list example, tuple example, set example, and dictionary example, with some values given. Now note that this is not 55, it is not 5, it's 55. They don't need to be ordered. That's why I just give such an example. And the more important thing is the last value 6 is repeated. Okay. Now later below we say print the number of values or number of elements in this specific data type, followed by the value of that data type, the content of that data type. For example, for the list, it's also written over here. The number of elements is 7 because 6 is repeated twice. Similar is true for the tuple. The only thing that changes is the sign. It's not square brackets, but it's regular parentheses. However, for the case of sets, it's not 7, but it's 6. And the reason is 6 is actually inserted once into the set. When you try to insert the same element to the set, it will actually not change. It will be the same value. So that's why we have 6 once, and therefore the number of elements is 1 less than the others. For the case of dictionary, it's not written here, we just forgot to write that one. But for the case of dictionary, it will be again the number of elements, just as with the others. But this time, remember, the elements are actually pairs. Well, actually, that means the number of pairs. So we have 1, 2, 3, 4, 5. We have 5 pairs. Therefore, when you say println dictionary example, it will write actually 5. And then these tuples. Not tuples, sorry, these pairs. Sorry. So, as a summary, when you use list, you're using the square brackets. When you use tuples, you're using the parentheses. For set, you use the set sign. For dictionary, well, again, you use the set sign. Now, how do you differentiate between a set and a dictionary then? Because you're using the same sign. Well, in the case of a set, each element is a single value, whereas in the case of dictionaries, it's a pair from key to value. Okay, so from that colon sign between the key and the value, you can differentiate the two. One other important thing is for the case of tuples, we talk about both for tuples and lists, we talk about index, but the tuples are immutable, which means you create it once, you cannot modify it. It's impossible to add an element to a tuple or remove an element from a tuple. If you want to do something like that, you have to create a new tuple with that element added or removed, whatever you want to do. But you cannot make modifications. You cannot enlarge or shrink a tuple. However, in the case of lists, you're allowed to do this. So you start, for example, as we did in the previous example, you start with an empty list and you keep on adding on top of that empty list. That's not the case with the tuples. So the tuples are created once and that value. For the case of set, again, you can start with an empty set and you can keep on adding on top of that set. However, the difference from a list is, number one, it's not ordered. Well, I'm going to talk about that ordering again soon. Number two, a set cannot have duplicate values. By duplicate values, we mean the same value repeated twice, 3 times, 4 times, whatever. Okay, so if you try to insert an existing element once again to the set, actually it doesn't do anything. It's just ignoring it. It doesn't give an error message either. It just ignores it. Okay. For the case of dictionaries, now we said in the case of set, the ordering is not guaranteed. Well, this is not exactly true. It was true, but starting with Python 3.7, sets now preserve the insertion order. That means in whichever order you inserted elements into the set, when you print it, it will be in that order. It's not alphabetical, it's not lexicographical or numeric values, whatever. It's just the order in which you have inserted. If you want to change that order, of course, you have to sort it, for example. Now, this was true for lists and tuples. When we come to sets, as I said, up to Python 3.7, but 3.7 not included, Python would say sets can have any order. Starting with Python 3.7, it's the insertion order. However, we still recommend that you do not write your programs with the assumption that Python is keeping it in insertion order. And the reason is that you write the program with that assumption, you give it to a person, but the person is using an old version of Python. Now, in that case, your program will work in a different manner, in an unexpected manner. Okay? So to ensure that you don't have such problems, since you cannot control which Python version they would have installed on their computers, to have a safe bet, we recommend that in your program, don't make that assumption that it is in insertion order. As I said, if that person is not using the new version of Python, it might cause problems. Now, how do you do the sorting? Well, you either use an existing sort function, there are many sort functions available, or you do the sorting yourself. Sorting is a complex problem. There are different ways of doing sorting. These all have different performances. Here we have the simplest implementation of a sorting. This is called selection sort. It's actually even the optimized version of selection sort. The real selection sort is a little bit more better, more performance-wise better than this one. But anyways, no need to go into that detail. The idea is simple. Consider students getting in line in the cafeteria in front of the cashier's desk. Okay, and let's assume the students are in different, they have different heights. Okay, some are tall, some are short, whatever. And let's say you want to sort them according to their heights in the increasing order. Now, how do you do this? The simplest sorting algorithm works as follows. Look at each student one by one. Okay, you start with the first and you go till the end. But when you start with a specific student, let's say in the order I, given that somehow everyone to the left is already shorter, you try to find any student to the right of this student who is shorter than the student. If there's such a student, just switch places and keep looking. Okay, so it's like, let's say initially you're looking at student number 0, the first one. So remember, the index is 0. So you compare it against 1. The guy is, let's say, taller, so ignore. 2, again taller. 3, let's say the student at index 3 is shorter than the student at index 0. So you just swap their places. So the old number 3 is now number 0, and old number 0 is now number 3. Anyways, these are the new numbers. So you keep on comparing against this new element. But at least I know that up to that point, that guy is the shortest, because I have looked at the previous ones. But there are still more students till the end of the line, so keep repeating it. So when you make a full pass over the line, everyone on the line, you are sure that you have found the shortest student, and that student is at index 0 after the first iteration. Okay, but that's all you know. So the shortest is at the first position, but the others are still mixed. Now let's repeat this process. Now look at 2 and try compare 2 against all students to its left. No need to compare with the student, to the right. No need to compare with the student on the left, because we know that's the smallest. So it's that guy is shorter than this guy. So no need to look at that. But are there any guys to the right who is shorter than this student I'm looking at? If so, do the exchange. So when you do the one full pass again, now you have the second shortest at this position, and keep repeating this. So that's exactly what we do over here. Now see, we first fill the array. We first fill the list using randint, generating random numbers and adding them to the list. Remember, to add an element to the list, you should be using the append method of the list. Anyways, when you come to this point, when you say print my list, your list is filled with random values. Now we want to sort those random values. So starting, now we have to pay attention, we have 2 for loops. So first look at the outer for loop. In the outer for loop, we are looking at range len my list. Remember, len my list is the number of students in my list. Let's say it's 10. Actually, in this example, it's 10. So it's from 0 to 9. Index is initially 0. So you're looking at element at index 0, in other words. Now for that element, we have another loop which will iterate from, now again, up to len my list. However, it doesn't start from position 0. Remember, that element was at index. So start looking from index plus 1, so from the right. So for index equals 0, start looking from 1 to 9. For when index becomes 1, you start looking from 2 to 9. When index becomes 3, you look at from 4 to 9. Okay, you go this way. But at any point in time, anyone to the left, we're sure they're smaller. Anyone to the right, they're in mixed order. So whenever we see a smaller one, we just do the flip to guarantee that when we're done with this pass, at that position, we have the smallest one. And keep repeating this. Finally, when you reach the end, everyone to your left, which means everyone actually, is sorted. And when you look to your right, there is no one. Therefore, it is sorted. This is how sorting is done in the simplest way. As I said, There are many different sorting algorithms. I'll not go over those because they're more complex and beyond the scope of this course. Anyways, we talked about lists, and each element of a list could be a string, could be an integer, float, anything. It could be a tuple. It could also be a list. Here we have an example of that. Now we have a multi-dimensional list. Actually, it's a two-dimensional list, starting with the square bracket, ending with the corresponding square bracket. But each element of this list is not an integer or a string or a double, but each element itself is actually a list. So in other words, timetable is a list of lists where the first element is this highlighted list, the second element is this one, and it continues in this manner. From here, you can generate three-dimensional lists and try to change values. I will not go over these. Please try it yourself. There are also three examples here using graphics. This is also left as an exercise for you, and this will be the end of this video.